Okay, so this is probably well known, but I only realized it last night. Just these ways of visualizing the trigonometric identities. So let's write them down. The basic ones. I guess I should write it big. So cos square alpha plus sin square alpha equals 1. I think we all know that. Sine of 2 alpha equal to 2 sine alpha cosine alpha, and cos of 2 alpha equal to cosine square alpha. So let's look at them one by one. So if we have a unit circle, this length is 1, and the angle alpha, this is also 1, and then pretty much by definition of...
What's that little squiggle there? Oh, that's alpha. Got it, thank you.
Good. So this section is cosine alpha, this height is sine alpha. Now if we draw this perpendicular, we can see this angle is alpha, so this angle is 90 minus alpha, and this is also going to be alpha. And our original right triangle is basically a right triangle with alpha, and so now we have two smaller right triangles which are also similar to the original one, except in this original one the hypotenuse is of length 1. In this one, in this right triangle, the hypotenuse is of length cos alpha, so the closer by side is going to be cosine alpha times cosine alpha, so cosine square alpha. And now looking at this triangle, we're going to have opposite side with the hypotenuse. So the hypotenuse is sine alpha, the opposite side is going to be sine alpha times sine alpha, which will be sine square alpha. So here we can kind of visually see cosine square alpha plus sine square alpha equals 1, which we all knew, but it's nice to see it. So with that as this first step, we can now look at the next step.
The red marker isn't so clear. Why don't you just use the black marker?
Okay. So here now we have the angle 2 alpha with the parts of which is alpha plus alpha, and we draw this chord across the 2 alpha and this perpendicular down. By analogy with looking at this triangle, which is similar to this triangle, we can see that this height is sine of 2 alpha. And by looking at this rectangle, we can see that this triangle, we can see that this side is sine alpha, and similarly this part is also sine alpha. So this chord length is 2 sine alpha.
Wait, which triangle gave you the sine alpha on the chord? Can you just make that clearer?
Yeah, let me. This triangle, which has a hypotenuse of 1 and an angle of alpha and the right angle here, you can see that the opposite side would be sine alpha.
Thank you.
And similarly with this triangle, so this length is twice sine alpha, and because this angle is alpha, this angle is 90 minus alpha, and then looking at this right triangle, we can see that this angle must be alpha as well. And now looking at this right triangle formed by the chord and the perpendicular altitude here, we can see that it has a hypotenuse of 2 sine alpha, and then this is the adjacent side, so that would be so this altitude would be 2 sine alpha times cosine alpha. So we can see that we had the sine 2 alpha and 2 sine alpha cosine alpha, and they're the same.
Yeah, baby, too good.
Okay, we have the most complex one.
Can you make the picture?
The cosine double angle identity. So we have alpha and alpha like before, and we saw earlier that this is sine alpha, and similarly this is cosine alpha. I guess maybe I can make that clearer. This part is cosine alpha. So we're going to draw a few altitudes here. Looking at this triangle, which is a right triangle with an angle alpha and a hypotenuse called cosine alpha, we can see that this length is cosine square alpha. Cosine square alpha from here to here, and we can see that this part was sine alpha, and we saw earlier this angle is alpha, and so this section is sine squared alpha, and now this distance is basically the right triangle with angle 2 alpha and hypotenuse 1, so this is going to be cos 2 alpha. So we can see cos 2 alpha equal to cos square alpha minus sine square.
Neat.
Great.
Thank you.
Thank you.